Okay, in this video we will continue our work with the parallel and perpendicular lines homework assignment. That assignment can be found in the description using the link. It's also right here. So I think we've covered number 1 to some degree, but I'll try to do a parallel line, because all the parallel line equations function the same way. And then I'll do a perpendicular line. I'll show you what we need to do for 2 and 6, and then we'll see where we go from there. I don't know how much time this is going to take. Okay, so it says here, write the slope-intercept form of the equation of the line described. Well, okay. So in order to write the slope-intercept form of the equation, we have to know what that form is. So the slope-intercept form of the line, slope-intercept, is an equation for a line that shows both the slope and the y-intercept. And that equation, does anybody know it off the top of their head?
No.
Y equals something.
Y equals bx.
Close. Y equals mx plus b. Now, in your calculator, when you go to linreg, under stat calc, and then you close linreg, it says ax plus b, because for some reason they have to be different. But this is the slope-intercept form that you're most familiar with. Okay, the y sometimes is referred to as f of x. That's a functional notation. And y is also the dependent variable. In other words, y depends upon x. If I told you that I make $1 billion every year, first of all, that would be awesome.
Mm-hmm.
The dependent variable is how much I make. The independent variable in $1 billion per year is the year. Remember, time is always the independent variable. The question you have to ask yourself is, does time wait around for anything ever, or does it just keep clicking on? It just keeps clicking on. So time's always the independent variable. So if y is the dependent variable, x is the independent variable. Okay, so we have m that we need to identify and b that we need to identify. So one of these is the slope and one of these is the y-intercept. Anybody want to take a shot at it? Anybody want to take a shot at which one's the slope and which one's the y-intercept? Which one? M is the slope. That's correct. Okay, now that we've identified the components of the y equals mx plus b form, Let's find an equation for a line that passes through 4, 3, which is parallel to x equals 0. Okay? This is a weird problem, and it kind of throws everything I just set up in the air. Because x equals 0 cannot be put into y equals mx plus b form. There is no y component. Let me show you what is actually going on here. Turn on the calculator and clear the memory. Hit second plus 712. Okay, and then hit the apps button, this one, the pink one, and go down to inequals and hit enter. Alright, I think you have to hit enter again, and now we're in this inequality. It looks kind of like y equals, right? So what I want you to do is cursor up to where you're hovering over there, on that x equals there, and then hit enter. Now watch what happens right here. It changes to x equals. Now we are given x equals 0, but if I put 0 there and graph it, you won't see. You won't see what's going on. So what I want to do is find an equation of a line that is parallel to x equals 0. And we are given these points, 4, 3. Which one of these is the x value? The 4 or the 3? The 4, that's right. So the 4 is the x value. And the y value is the 3. Alright? So what I'm going to do is graph a line for x equal to 4. And let's see what that line looks like. What I'm doing is I'm trying to move this calculator out of the glare of those spotlights. Okay, so let's put in here x equal to 4. Okay, so x equals 4, and now I want to hit graph. Okay, now what it graphed was it graphed this blue line. It's a perfectly vertical line. See, it has an undefined slope because all of the y values, say here's y1, y equals 1, y equals 2, y equals 3, y equals 4. Anytime I run this out, I'm going to run into the same x value of 4. And that's why lines that are perfectly vertical are not functions, because it fails the vertical line test. And one way you can actually prove that to yourself is, let's say that I have two y points. It doesn't matter what they are. It can be 4 minus 3. If I put it over my, this is y2 minus y1. If I put it over x2 minus x1, I'm going to put it over 4 minus 4. It really doesn't matter what's going on up here, because 4 minus 4 is 0. I can't divide by 0, so this whole thing becomes undefined. That's why it's an undefined slope. Okay, if the slope is undefined, it's perfectly vertical at that point. So, if you want to find the equation of a line that passes through x equals, or is parallel to x equals 0, and passes through 4, 3, you need to find this equation, x equals 4. And that's the answer to number 2. As far as graphing it goes, you just need to show something simple, like this. And then I'm leaving it dashed, but you can draw it all the way in. Okay, so just so you can see what I'm doing, I'll color it in now. So there's your equation of the line x equals 4 graphed, and the original equation, x equals 0, I'll use a different color because it's actually right on this axis line. It's hard to see. So that's the complete solution to number 2. Okay, on to number 3. This one we might actually get to use the stuff we know about y equals mx plus b, because we're given y equals 3x plus 2, and we're asked to find a line that's parallel to it and which passes through the points 2, negative 4. So let's talk about what parallel means. If I have two lines and I want them to be parallel, let's use a piece of scratch paper here. If I have two lines that need to be parallel, like this and this, they have to share something in common. Okay? And that thing that they share in common is something that these two lines do not share in common, and that these two lines do not share in common. What is the thing that these two lines share in common that these other lines don't? Yeah, these are definitely not parallel, but mathematically the reason they're not parallel is because they have different slopes. Remember, slope is like the mountain. Okay, the mountain. If we have a positive slope, we're skiing up the hill. Okay, they're skiing up the hill. If we have a negative slope, that's a positive slope, skiing up the hill. If we have a negative slope, we are skiing down the hill. So that would be a negative slope. All right, so these both have negative slopes. They're going down the hill, and they're the same slopes. They're identical. Here we have a negative slope going to the left, and we have a negative slope going to the right, but they're not the same. And actually, this slope here is not negative. I misspoke. That's a positive slope. Okay, it just happens to have the pointing down, and then here's a negative slope. So that's why those aren't parallel. These slopes are also different. Here's a positive slope, and even though that arrow is pointing up, here's a negative slope. These slopes are both negative because on the mountain, they would be on the right side of the mountain going downhill. Negative slopes. The key is that they have to be the same slope. Parallel means same slope. Every time you see parallel, you know it means same slope. And the variable that we use to identify slope means m. So we need m to be the same for both. So first things first, let's identify what the slope is for the line that we're given. What is the slope for the line that we're given?
We're giving 3.
3?
Y equals 3x plus 2.
That's yes, that's very good. That's the equation of the line that we're given. But back here I heard somebody identify the correct slope. M is equal to 3. So if the slope is 3, what is the y-intercept? 2. 2 is the y-intercept, and we refer to 2 with the letter b. That's the y-intercept. So now I have y equals mx plus b. What I'm going to do is graph this. I want to see what this looks like. I'll graph it on the calculator, but what you're going to do for your homework is you'll graph it on a piece of graph paper. Okay, so what I need is my whiteout. Where did that go? Here it is. So you need to kind of draw a graph like this. We're going to use these grid lines as unit intervals. So we're actually going to graph this like professionally. So we were given the line. The line we were given is y equals 3x plus 2. Question. If the slope is 3, and 3 is a positive number, what side of the mountain am I going to be on?
The left.
The left side. Good job. Good job. Yeah, you're going to be on the left side. So this is going to be a positive slope situation. So I don't really know what my line's going to look like, but I know it's going to be going up like this. Okay, so the way you plot lines is, we'll make these intervals big. We'll call this, I'll make mine, every 2 will be 1. So like I'll go up 2 squares and make that 1, up 2 squares and make that 2, up 2 squares and make that 3, up 2 squares and make that 4, etc. 5, 6, 7. Same thing on the x-axis. Okay, this will be 1, 2, 3, 4, 5, 6, 7. Now I'm ready to graph. In order to graph a function that you're given, or an equation you're given in y equals mx plus b form, you need to start at the y-intercept of 2. So the y-intercept is where x is 0 and y is 2. See, this is the x-axis. So like here, x is 1. Here, x is... What is x right here? Where my pen is? 6. What's x right here? 4. What's x right here? 0. Okay. So x is 0 and y is the y-intercept 2. So I'm going to put a dot there to let me know that's where I'll start drawing my function. And now we need to remember, and slope m equals rise over what? Run. Rise over run. Now in this case we are given a slope of 3. And it's like, well, what's the rise and what's the run? Well, 3 can always be written as 3 over 1. We typically don't do it for convenience. So the rise is 3 and the run is 1. So let me demonstrate how to actually plot this. So we're starting at the 2 point on the y-axis. We're now going to go up 3. So up 1, up 2, up 3, over 1. So I'm going to move to the right 1, right there. And I'll bubble in this point. Okay? And if I wanted to, I could do another one. I could go up 1, up 2, up 3, over 1. Plot that point there. You could keep doing this all day. And I'll just show you another way. Sometimes you run out of space. So you have to kind of do reverse plotting. So instead of going up 3, over 1 to the right, the same thing can be accomplished by going down 3 and over 1 to the left. I'll just prove something to you. Take a straight edge, and you should be able to line up all of your dots along the edge of that straight edge. If you did it right with the graph paper, they should all be there. So be very careful. Make sure that you're going to draw your line passing right through these grid marks and draw in your line. Okay? Cap it off with the line marker, the arrow, so people know it's not a segment. And then you're going to label this line y equals 3x plus 2. That's how you'll know to refer to that. Sometimes you can use a highlighter, or you can use different colors to draw your lines so that you keep track of them better. So the highlighted yellow go together. Okay? Well, now what? Let's go back to our problem. We were told that we need to find a line that's parallel with the same slope to this curve, which we just drew, going through point 2, negative 4. So what we need to do is go back to our graph. We need to plot the point 2, comma, negative 4. Now, 2, comma, negative 4, which one is the x value? The 2 or the negative 4? The 2. So write x underneath that, and then negative 4 must be the y value. So I kind of need to draw in, because I got, this is 0 point here. There's 1. So I got to go down 2 boxes and put negative 1, down 2 boxes and put negative 2, down 2 boxes and put negative 3, down 2 boxes and put negative 4. Okay? Negative 4. And what it wants me to do is plot at negative 4 where x is 2. So where is x? 2. X is 2 right there. So now we starting there, we move down to where this negative 4 is. So 2 comma negative 4 is that point right there. Okay, so put a little dot there. Now what we want to do is find a line, the equation of a line that's parallel to this line. Okay? So, you know, visually, it kind of looks like I should just be able to do that. But, you know, if you're into trade work, you know you have to be a lot more exact than that. It's like, is that parallel? Or is that parallel? Is that parallel? See how it could be? Visually, it's not clear. So there's got to be a better way than just trying to eyeball it. Well, there is. I'll show you how to do it. We're going to use something called the point slope formula. We're going to use the point slope formula. There's point slope formula, and the point slope formula is y minus y1 equal to m open parentheses x minus x1 close parentheses. There's the point slope formula. All we do is we plug in our m value, which we already know is 3. So m's going to be 3. And then this is x1, and this is y1. So 2 is x1, negative 4 is y1. So you're going to plug in here a negative 4. Be careful with that negative sign. And then for x1, we'll plug in a 2. It's really a game of plugging in values. Right? So they call this substitution. We're substituting the negative 4 for y1. We're just going to kind of rewrite this using our numbers this time. So y minus, open parentheses, negative 4, I have a minus minus there, equals 3, open parentheses, x minus 2, close parentheses. So now I kind of need to simplify and distribute and solve. What I'm trying to do is get y all by itself on the left side of the equation, and I want this thing to turn into y equals mx plus b form. We're almost there. So the first thing I can look at is this y minus minus 4. What can I do here? I got 2 minuses. 2 minuses make a
Negative.
positive.
Oh, positive.
2 negatives make a positive. So here, this is going to become y plus 4. Y plus 4 equals, now distribute the 3 like this, so we have 3 times x, which is just 3x, and then 3 times negative 2, so I've got negative 6. Now to finish solving, I have to get rid of this 4 over here. I got a positive 4 next to the y. He needs to go over here. So I've got to subtract out the 4 on both sides. And 4 minus 4 is 0, so that cancels out. Which leaves me with y equals 3x, and then negative 6 minus 4 becomes a bigger negative number. So it's almost like adding 6 and 4 and sticking a negative sign in front of it. So that's negative 10. So 3x minus 10. This is actually in mx plus b form, isn't it? And that is the equation of your parallel line. So real quick before you go, let's plot this out. Y equals 3x minus 10. What we hope is that this passes through 2 comma negative 4. All right? So this is 2 comma negative 4 right here. The slope was 3. So we're going to go, starting at our plotted point, we're going to go up 3 over 1. Okay, so there's a point on the curve. Up 3, 1, 2, 3, over 1. I'll even plot one more. 1, 2, 3, over 1. Okay, so now I've got this line plotted. Let's graph it in by lining up our points very carefully. Okay. Looks parallel to me. And as a matter of fact, it is mathematically perfect. So this is the equation of this line is y equal to 3x minus 10. What minus 10 means is if I were to extend this line out until it hit the y-axis. Let me just do that real quick for you so you see how this works. Let me just draw this line all the way out. Okay. And then draw my y-axis all the way out. This point right here should be minus 10. Let's see if it is. Here's minus 5, minus 6, minus 7, minus 8, minus 9, bingo, minus 10. Kind of verified that we were right. So that was our y-intercept for our parallel line, and it matched graphically what we did. So this one I would usually highlight with a different color, like purple or pink or something. And I don't know if I have. I don't know. Here's it. Yeah, here we go. It's good to carry a couple colors here. I'll highlight this one in pink so that you know which line goes with the equation. And that is how you do number 3. Okay, we'll stop the video there and pick it up later with the rest of the problems.